Welcome to this video on measurement conversions. As we enter the world of conversions, it's really important that we understand the process that we go through. And there are going to be conversions that you just know off the top of your head and you can spit it out, and that's great. But it is important that you work through the process, because when you get to those that you don't know off the top of your head, you got to be able to pull from within. So we're going to kind of start easy. And number one, how many days are there in 6 weeks? Well, we can probably, think through ourselves and say, well, there's 7 days in 1 week, so 7 times 6, that means there's 42 days in 6 weeks, right? And I determined this because I know that 7 days is 1 week, so to get 6 weeks, right, if I went from here to here, I multiplied by 6, so I multiply by 6 and I get 42 days, right? There's kind of the mindset if you were explaining how to do this. Well, this right here we call an identity ratio. 7 days equals 1 week. So when you think about these identity ratios, they allow us to kind of set up an algorithm, a step-by-step procedure to solve these problems. Now, if you wanted to kind of set up an actual mathematical problem with this, we always start with, well, what do you have? Well, we know that we have 6 weeks, and I'm making it a fraction because our identity ratios we use as fractions. So I can multiply that by, in 1 week, there are 7 days. And if you think about multiplying fractions, we know that from the numerator to the denominator, you can reduce if you have common factors. Well, the label of week is common in the numerator and denominator, so I cross them out there in green. And you'll see I have 6 times 7 in the top, which is 42, and my label becomes days. Right, so this is the process that we want to kind of think through as we do some conversions. So that's when I talk about identity ratios. So 60 seconds to 1 minute is an identity ratio. 12 inches to 1 foot is an identity ratio. 1 foot to 12 inches, right? They can go either way. So these identity ratios are simply a fraction, or a ratio written anyway, really, where the two pieces are equal just in different units, right? Seconds and minutes, both measuring time, but different units of time. Okay, so we're going to use identity ratios to continue on. Now, we are going to use the process for all of these. So how many days are in 16 weeks? And you might think, well, how do I know what to start with? Well, what are you given? I'm given 16 weeks, so I'm going to start, and I'm just going to put it over 1 to make it a fraction. Now, when you're going to the next step, you want to get rid of weeks. Well, if you have weeks in the numerator, you've got to put weeks in the denominator so that they'll cancel out with our whole multiplying fractions concept. And I'm going to days. Well, I know 1 week is 7 days. So that right there will make my weeks go away because they're in the top and bottom, and I just have 16 times 7. Since they're both in the numerator, we simply multiply. And 16 times 7 is 112, and my label is days. You want to make sure you're labeling your answers for these problems. The next one, we have an average pregnancy is 280 days. How many weeks is this? Well, now we're starting with 280 days. Okay, so when I multiply the next piece, my label in the bottom has to be days, because I need my days to cancel out top to bottom. And we're changing to weeks, so I need weeks on the top. What's the relationship? Well, 1 week is 7 days. So that makes my label of days cancel out, and now you see how the 7 is in the denominator. So because we now have the 280 on top and the 7 on the bottom, that's like saying 280 over 7, or dividing. So anytime there's a number in the denominator, you divide. 280 divided by 7 gives me 40, and my label is weeks. So the average pregnancy is 40 weeks. Using some more, maybe something that's not as familiar, right? When we go with identity ratios that you use 7 days in a week, those things are a little bit easier to just come up off the top of your head. But I'm not sure how many of you know that 1 hand is 4 inches when you're talking about horses. So when you're talking about two identity ratios, well, one of them would be 1 hand is the same as 4 inches. And the other one is simply reverse. 4 inches is 1 hand. And you may be thinking, why are there 2? Well, look at where your labels are. And if you think about it, we wanted, it's all about the labels being in opposite positions, one on top, one on bottom, that cancel out so you can complete the math. So it's going to depend on what we want in the bottom of what we're going to use. So you got to kind of let what you have and where you're going dictate which identity ratio you use. So in number 2, we're going to use that ratio, the 1 hand to 4 inches. The world's tallest horse, Big Jake, is this number of hands tall. So you'll see we are given 20.6875 hands. Labels are super important when you're doing conversions. Now, when I'm deciding what to multiply by, look at your labels. We have hands on the top, so my label of hands is going to go in the denominator, and I know that 1 hand is 4 inches. So that right there makes my label of hands go away, and then I can look at my math. In both numbers are in the numerator, so I multiply 20.6875 times 4 gives me 82.75, and my label is inches. The world's shortest horse, Thumbelina, is 17.5 inches tall. How many hands is this? So now I start with 17.5 inches. Put it over 1. When I look at my other piece, I look at my label, inches. Inches on top means I'm going to put inches on the bottom. So I'm going to use 4 inches is 1 hand. That makes the inches label go away. And now since the 4 is on the bottom, I'm going to divide. 17.5 divided by 4 is 4.375, and my label is hands, right? Because that's the label that's left. The average Clydesdale is 18 hands tall. How many inches is this? I'm starting with 18 hands. Put it over 1. So, hands in the numerator to get rid of it, hands in the denominator, right? I always start with my label because that's kind of how you know where things go. And then I know that 1 hand is 4 inches. I use those identity ratios. The hands label go away. 18 and 4 are both in the numerator, so I multiply, and I end up with 72, and my label is inches. Now let's go to a new identity ratio. In horse racing, the distance between horses in a race is measured in horse lengths. 1 length is 8 feet. Write 2 identity ratios you can make from this information. Okay, so I know that 1 length is 8 feet. To get the other one, I simply reverse. 8 feet on the top, 1 length in the bottom. And again, it depends on what you start with and what you need, what label you need in what spot in order to cancel them out. So let's just do one problem like this. In 1973, Secretariat won the Belmont Stakes by 31 lengths. That's a lot. How many feet is that? Well, 31 lengths is what we start with. So when I go to say, okay, what am I going to multiply by? Lengths in the top to get rid of it, lengths in the bottom. And I know that 1 length is 8 feet. So that ratio allows my lengths to go away. 31 and 8 are both in the numerator. 31 times 8 gives me 248 feet. And that, my friends, is the beginning of our conversions.